Okay, so today we're going to be talking about EKG recordings and kind of how they're measured. So, first, here is what's called biphasic action potential. And this is just an entire electrical event for a heartbeat, basically. So, I put electrical event for a heartbeat. So, this is based off of like extracellular measurement. And we'll go over this in a second, but basically it's like the charges and like the extracellular. So here we have, let's say, two nodes, which are placed here. So that's going to be, or sorry, not nodes, like little patches when you're doing your EKG. You put a patch on one side of the heart and the other, as shown down here. And so you have those patches, and that's what's going to measure the spreads. So say we have our E1 and our E2. So how this is measured is it's our E2 minus our E1. So here it's a positive because our E2 right here is positive minus a positive because it's positive right here, which is going to equal 0. So that's why we have our flat line right here. So that's the start of our EKG or our biphasic action potential. Then we move down here to the second recording. And so this is positive minus a negative, which is going to turn into a plus. So it's going to become positive, which is why our EKG starts to go up. So then we move down here. It's going to be a negative minus a negative. So that equals 0. So it goes back down to 0. And then we have a negative minus a positive, which is going to be negative. So it's going to decrease past 0. And then we have, once again, our positive minus our positive, which is 0. So it returns back to that resting potential. So that's kind of how we see this flow and how we calculate how it increases and then how it decreases and returns back to normal resting rate. So that's kind of how that's calculated. Then we can move down here, and this is just a good kind of description. You can see the charge spreading throughout each part of the heart and where that's at within the EKG. So it's really helpful. And via our gap junctions up here, this is just like the spread of depolarization. And yeah, so we can see how it completes like one whole cycle over here. Nice just to be able to kind of correlate um, each part of the EKG. So also to kind of, I'll go down here and show. So in this EKG, we have our relationship of our um, EKG and the contraction or like the action potential. So up here on our EKG, we can see the names of the um, waves. So we have our P wave, which is this little increase. This is our atrial depolarization. This is our QRS or ventricle depolarization. And then our T wave, which is our ventricle repolarization. So that's like those waves. And then you can see how it is um, correlated. So when this increases significantly, that's when that ventricles are about to contract. So it's super helpful to be able to compare that and learn how to, kind of calculate the action potentials.